Good morning. We're going to continue now with Alec Gleason from Cisco. And just a reminder, if you want to ask a question, if you please stand up and we'll pass the mic to you. Alec?
So I am Alec Gleason, a security consultant with Cisco, and this is a primer on attacking and defending DevOps. So at Cisco, especially in our security consulting arm, we love developers. A lot of us come from development and operations background. It's one of our not so hidden passions alongside security. So that's something that we bring into work every day. A bit of history about me. Before going into penetration testing and security, I spent time as a development operations engineer for a very agile company. Spent some time as a systems administrator as well. Up on the screen is my Twitter handle I never use, and love being at Cisco now. So the funny thing about DevOps is that everybody has their own definition of what it really means. To some, it's continuous integration. To others, it means they're using Chef, or they've got environments existing as code. And the definition we're going to try and stick with for today is that DevOps is the application of agile methodology to systems administration. As we've heard earlier today, it's more about culture than anything else. And all of this automation, all of these really cool tools are just there to help facilitate that culture. And as Adrian Cockcroft of Netflix said, we're used to seeing servers as pets, right? Everybody's got that old 15-year-old server named Sparky that they know that they have to reset every 72 hours, maybe hit the left half of the chassis every once in a while to get the drive spinning before it comes online. That's a lot of old systems administration. We still see a lot of that. But servers and infrastructure should be more like cattle, where if you see a problem, if the cow gets sick, you need to diagnose what's wrong, and then you take it behind the shed and you move on. Environments are supposed to be reproducible. They're supposed to be constantly changing, and you should be able to spin them up quickly. That is one of the big tenets of the DevOps culture. So today, we're going to go through really two war stories, two big experiences that I had to, and us as Cisco has had to kind of generate this presentation. Like, why is DevOps security important? Well, we ran into these two experiences that were really like, whoa, hey, this is something big. This is something we might want to, start to research a little bit more, throw a few presentations together. One of them is, holy cow, what have we just uncovered? What have we just done to this company's infrastructure? And the other story comes from the more blue side of things. Sorry, back in my DevOps days, holy cow, what could the bad guy have done if they had discovered this before we had? So the first example is a provider for third-party platform as a service, very large company that all of you guys are aware of. A lot of effort went into the traditional application and network security, right? Developing the applications so there aren't any cross-site scripting or SQL injection, trying to segregate their networks as properly as they can. And for the most part, they did a pretty good job of that, except for one of those vulnerabilities which let us get a shell on the box. But that's not where the real scary stuff started. It happened after we got access. So they were using Docker containers. So all of their applications are in a nice little package, pretty segregated from each other. But we noticed that the host and the container were being managed by Chef due to some artifacts that we had discovered on that node that we interacted with. And those artifacts actually pointed us back towards a service called Chef. Chef, we've heard of that before. Now, Chef is a tool for allowing code to represent environments or to have environments exist as code. If you want to deploy an Apache web server, you'd write up what Chef calls a cookbook in Ruby, click a button, and suddenly you have a brand new web server that was set up from scratch. And this can be pointed at AWS or Google's compute engine. A lot of these hypervisor and platform as a service providers utilize this technology. So what can we do with it? Well, Chef has this wonderful web interface that lets you orchestrate all of the servers that Chef uses. So if you need to spin up domain controller, web server, this is the web interface that you see. Now, first of all, we should not have been able to see this, but we did. And second of all, we ran into Heartbleed. So this allowed us to mine information on the service until we were able to retrieve valid credentials for this web interface. So we logged in. And we saw some cool stuff. Some really cool stuff. Some really cool stuff. We were able to see, modify, and deploy a lot of different server types. This is in Chef where you would say, hey, I want to deploy a domain administration server. Hey, I want to deploy a web server. Well, we had access to all of that. Now, with Chef, they have these encrypted data stores for storing hard-coded credentials and passwords and everything that ends up at the machine. So after poking around the server, we weren't able to recover that, but we knew that those credentials, those encrypted artifacts, had to be plain text on the endpoint at one time. Why? Because that's how it has to be used. So what did we do? We deployed our own. We gave ourselves root access. We deployed a server with every role possible on it. And suddenly we had access to the keys to their entire kingdom. And I mean absolutely everything. Servers, services, SSH private keys that were being shared. We were able to see everything and do anything, even outside of the scope of the technology that we were assessing. So the other story comes from a different side of things. We're doing internal security reviews. Back when we were a developer at this company, it was a very high priority that teams do kind of initiated penetration tests against their own software to try and catch bugs before they really make it to production. And this is one of those instances where we got very lucky by finding something. So the team I was on it was called the DevOps team, and it was a team of individuals who were there to facilitate the DevOps operations of the entire organization. The big keynote project of this team was to develop a continuous integration platform that essentially you would push source code to a code repository. It would automatically build it, automatically deploy a container around it, and send that straight to production automatically, completely hands-off, if that's the state that code is in. Now, GitHub was hooked to do this, a lot of really cool functionality built around this, but the one big piece is that we found a bash injection vulnerability. When it comes to building programs, sometimes you need to add more flags. We want to build this in debug mode. We want to use these credentials instead of those. So that was a text input field in this web interface that allowed developers to manage this build process. So what did we do? We found that you can just put a semicolon there, start typing in bash commands, and now we're executing code on the server infrastructure that builds, manages, and deploys every application used by that company. So in turn, we had the ability to backdoor, to modify, to absolutely wreck every piece of software that company uses and pushes to production. That's another type of thing that can completely end a company. DevOps is really cool, right? I mean, I know a lot of this short presentation covers the war stories, the things gone absolutely wrong, but DevOps is really cool. And if it's used properly, it can be a huge gain for security. The biggest issue with it is there's magic in DevOps, right? You write a 15-line script and you click a button, and now that script is a full-blown server that's sitting on your infrastructure somewhere, right? DevOps can be magic. But the problem with magic is that it hides complexity. And hiding complexity normally means that you're hiding bugs as well. So to get DevOps right, to get DevOps and security right, you really have to go the whole 9 yards, the end-to-end, make sure every single component of your infrastructure, of your workflow is built, architected, deployed, and managed securely. But until we get all of that figured out, we have the state of DevOps security at a lot of organizations. So normally in this presentation, talk about a lot of different technologies such as Docker and GitHub and all these DevOps tools. But for the short period today, we're just going to talk about one, and it's everybody's favorite, the cloud. But specifically, we're going to be talking about infrastructure as a service. Now, this is the Google App Engine, Google Compute Engine, Amazon Web Services. These all lump into that category as infrastructure as a service. That's rack space, pretty much anywhere you want to deploy servers somewhere else. And so they do hosting of servers, data storage, application storage, things like Amazon's Lambda for having stateful applications, not a full-blown server, platform as a service. And this is really important to DevOps because a lot of these companies are moving to those platforms. They want their services and infrastructure out of the data center and into a place where it's easier to scale and somebody else really has to do the hard work of managing the wires and the servers and the actual hardware. So from a pen tester's point of view, right, this is kind of what we look for if we're doing a penetration test against infrastructure. We end up on a server somewhere, either through some application vulnerability. How do we determine whether we are on a AWS instance? And that's basically what these slides are going to focus on, is AWS. So really, IP ranges are the biggest giveaway that we have found ourselves to a AWS managed node. Certain provider-specific details I know listed. We have etc init scripts that represent EC2. There are actually metadata servers that are only accessible through devices on the AWS network. And the same thing holds true for Google's Compute Engine. So really, if you know this URL endpoint, you hit it, and if you get any type of response back, you know you're in AWS. Now, there are also other places that you would look for AWS on your developers' machines. There are command line tools and interfaces that work with Google, that work with AWS. I believe it's the AWS command line tool. There are files such as Bodo files, which hold credentials. So if we end up attacking a developer's machine or gaining access to some sort of development server, these are the type of things that we look for too, and they can lead to some really, really juicy things. So, okay. We know we've got access to AWS. We're either on a node or a developer's machine. What do we look for if we're an attacker? Well, the first thing is key pairs. So the way that Amazon and all of these other IaaS providers allow access to the infrastructure to be able to remotely set up hosts or access data storage is through the use of basically public-private API keys. So if you're able to recover those, well, now you've gained access to another piece of infrastructure. With DevOps, one of our priorities is pivoting as opposed to maintaining access, since you have companies like Netflix who are spinning up and destroying Docker containers at insane rates, going through hundreds of thousands a day, and Google who are going through millions, if not billions, of containers every month. So finding access to larger pieces of infrastructure and other pieces of infrastructure become a higher priority than maintaining access on the current system that we have. So we look for those API keys. We dig around and try and find these Bodo files, which sometimes contain even plain text credentials, developer-specific API keys. If we have access to those command line tools, we also have the ability to look for currently authenticated users. Sometimes these tools cache credentials and sessions in order to make life easier for developers. And if we can recover those, we really sometimes have keys to the kingdom. In one example, we had a developer accidentally leave themselves logged in to the Google Compute Engine command line interface on a production machine for a long time. And we were wondering why this machine wasn't pushing data to the correct place. And it turns out because he left himself in, all of the data on that server was being pushed to his private storage repository instead of the production storage repository. Now, we found this, again, doing a blue team exercise. And when investigating what the impact could have been of him leaving his credentials there, well, he had full administrative privileges. So if anybody had also gained a shell on the machine, they could have used that Google command line interface to just suddenly have removed every managed node that was being hosted there. If this was the Amazon client, every AWS instance could have been wiped off the face of the planet because this developer was a little bit sloppy with using his credentials. So this is the type of risk that you see when these bits of information are accidentally left in places they shouldn't be. So here's just a quick example of finding AWS keys within an application. So really, when you're doing all of this automatically deployed infrastructure, a lot of times these credentials, they have to end up somewhere. So they're pushed in either files, in environment variables, but somehow they have to end up on the end machine to be used. So this is where we whipped through a Python application and was able to recover the AWS keys for a specific user. Now, it turns out that those AWS keys were not provisioned with the principle of least privilege in mind, which means those keys had the ability to push and pull any type of data within Amazon S3, as opposed to just the type of data that that application was required to maintain. AWS sometimes leads to other issues and things that you have to keep in mind. I know DevOps, one of the big tenets of that is to have a unified monitoring or resource management system, like Splunk. Something that will collect logs from all of the endpoints, from all of the nodes, aggregate them, and make them searchable. It's really easy for operations personnel to be able to look through tools like Splunk, identify anomalies, identify things that are not working properly, and resolve those issues. But a lot of times you see these unified tools. You see it with continuous integration platforms, sometimes even self-hosted Git repositories. They add a path to bridge those different network segments. For example, here, this was a screenshot of a Splunk instance, the web interface that was allowed to be accessed through an AWS instance. The mentality of the network engineers there was, hey, all these devices need to be able to access Splunk to push their logs. So they gave all servers in AWS access to see Splunk. Well, unfortunately through this was the standard, the community version of Splunk, so there was no authorization, no authentication in front of the system, so we were able to be logged in as an admin user and eventually escalate some of the things that we found within that Splunk instance to gain server access to other infrastructure on multiple networks. Essentially, we used this one service that was required to be in the middle of all of the network segments to travel between all of the different network segments. So really, and as it comes down to be with a lot of DevOps tools and technologies, it really comes down to go back to the basics. Right? Access control, access control, access control. If you're doing things with API keys, right, as we saw in the example, deploying them to be able to allow different applications to push and pull data from different services, use the principle of least privilege. Only allocate API keys with permissions enough to access the data that you specifically want, not just everything because it's easy. And in an ideal world, each application should have its own set of API keys. You should not be sharing them even between same instances of applications. When it comes to provisioning access to developers, same idea, just least privilege. Only allocate what is minimally required to allow that developer, to allow that application to get the job done that it needs. And another thing that we see is that hot fixes are for development. They are not for production. Now this goes back to the Adrian Cockcroft quote, right? Your servers should be cattle. They shouldn't be pets that you want to go and fix up on the spot. When it came to that story where the developer ended up logging in with his own credentials on the machine and left them logged in, providing access to pretty much everything, that's the type of thing you don't want to see with DevOps. That is an example of a hot fix gone wrong. And really, the final big piece there is to compartmentalize, to make sure network segments are appropriately restricted, to make sure that access to those pieces of infrastructure are at their minimal level. For example, with Splunk, make sure that only the log reporting tool is what's able to be accessed from those production networks. You only need to hit those 1 or 2 ports to push the logs over. You should not be able to see that web interface. So really, when it comes to DevOps, and touching back on what we started off with, these really powerful centralized tools become very powerful points of ownage for a system, for an organization. There is a lot of that magic. I mean, anytime you can just click a button or with a single command perform really complex applications. For example, with some of those chef things, a single button means you deploy a new instance on an AWS server, you set up a new node, you build a Docker container, you push a Docker container, all from a single button. Now that's really complex, cool stuff. But that magic does hide that complexity. And the complexity does lead to bugs, and it does lead to vulnerabilities. And really, DevOps is awesome. It's a huge gain to the industry. It's a huge gain to security, but only if it's done end-to-end, with security considerations made every step of the way. Thank you, guys. Originally presented this with Patrick Thomas for Cisco and at several OWASP meetings. If you have any questions, I'll be available here to take a few. I'll also be stepping off to the side as I think I'm eating up a little bit of time. All right, thank you very much.